Hello everyone, welcome to today's video. So today we will be talking about distillation columns. Yes, one of the most questioned about topics over mail and over a lot of messages that we have received. Please talk about distillation columns and the type of questions that are generally asked in campus interviews or company interviews regarding distillation columns. So today we will be discussing about the basics of distillation columns. What are distillation columns? Where are they used? Why are they used and how are they used? That is the basic working principle for distillation columns and the type of questions that you can expect in an interview room from distillation column. So I would request you to see the video right till the end to know the type of questions that are being asked generally from distillation columns and how they are being approached upon. We will make further videos on distillation columns, different types of distillation column, the design of distillation columns, Macquarrie diagram, Ponchon-Savarate method, different kinds of distillation column, multi-component distillation column, Lewis-Mathieson method. We will try to bring up all of those, but today we will just talk about the basics of distillation column so that you understand the operation of a distillation column and where and how distillation column is being used. So primarily speaking of distillation columns, when we hear this term, the thing that should come straight away to our mind, to your mind, is liquid-liquid separation. That is, in any type of liquid-to-liquid separation, supposedly A and B are two liquids intermixed with one another. The most common method of separating A and B, which are intermixed in a mixture, to separate the two is distillation. Distillation is one of the widely used methods for liquid-liquid separation. That's why I have written liquid-liquid separation. Like when we talk about liquid-gas separation, absorption and stripping is what comes to our mind. When we talk about solid-solid separation, froth flotation method, then density difference separation, or mechanical operations like sieve separation, molecular sieve separation due to difference in sizes and difference in densities are being definitely used. When we talk about gas-solid separation, cyclone separators, gravity settlers, back filters, these are the things that come to our mind. Similarly, when we talk about liquid-liquid separation, crystallization, liquid-liquid extraction, and distillation column is that comes to our mind first when we hear about liquid-liquid separation. That is, there is a liquid A and there is a liquid B and they are in a mixture and we need to separate the two. The mixture may not be necessarily of two materials. If it is a two material mixture, that is only A and B, it is called a binary distillation. Binary distillation, that is the orthodox distillation method that we usually talk about when we talk about distillation. Until and unless in the industry you mention that it is a multi-component distillation, it is being assumed primarily that you are talking about two dominating liquids which are to be separated from each other and you are applying the distillation method known as the binary distillation. Now, binary distillation can be tertiary distillation, which is other than binary distillation, that is more than two component and is popularly known as multi-component distillation. Yes. So supposedly A plus B plus C is in a mixture and you need to separate out A such that you obtain A as your pure product, and further the B plus C is separated and is treated in a separate distillation column wherein B and C are individually separated from each other. So you see, distillation columns can be used up in series and is used up in series often in the industry to separate three components. That is, to primarily obtain A from the chamber and to then separate the mixture of B and C separately in a different distillation column, obtaining B and C separately if you wish to do so at all. If your primary motive is to separate A only, let alone B and C may be in mixed form. So to separate A only, you may need one distillation column specifically to separate A, and the characteristics of the distillation will be judged by the boiling points and the volatilities of the compounds that are being separated. Very important two concepts that you must keep in mind when you hear about distillation columns are boiling point BP, boiling point of the components that you are trying to separate, and the volatility of the components. What is the volatility? Volatility is a tendency of the liquid to easily vaporize or easily form vapors and travel upwards. So you see, the more volatile liquid will always have a tendency to form vapors at lower temperatures and will always try to move to the top rather than coming to the bottom, whereas a low volatile compound will always have a tendency to form liquid and it will not easily vaporize. So the vaporization tendency of a liquid is volatility, and the relative volatility of two liquids is definitely one relative to another. Supposedly the absolute volatility of a compound is 1.5, the absolute volatility of another compound is 3. So the relative volatility of the second compound with respect to the first compound is going to be 3 divided by 1.5, which is 2. So this is my mu relative of the second compound with respect to the first compound. So we see that we can predictively say that the second compound is twice as volatile as the first compound. So since the second compound is twice as volatile, so it will have an increased tendency to form vapors, whereas the first compound, being less volatile in nature, will not easily vaporize and will have a tendency to remain as liquid. And this virtue in particular is being used in the industry, in the distillation columns, to separate the liquid, to separate two liquids, such that one liquid out of the two liquids or the three liquids primarily tries to form vapors, and another portion of the liquid primarily tries to remain as liquid. So my feed basically will have a mixture of components, A plus B plus C plus D, depends on whether it's a binary distillation, that is two component distillation, A plus B only, or it is multi-component distillation, like in this case A plus B plus C. It is a multi-component distillation. The treatment of the design of this distillation columns, the multi-component distillation column and the binary distillation column, are different from each other. Binary distillation columns are much easier to design, and multi-component distillation needs Excel sheet. You cannot theoretically calculate. Even if you can, it is a hectic procedure. Generally, we need Excel sheet to undergo the Lewis-Matheson method to design a multi-component distillation column. But we will primarily talk about, for the basics, we will talk about only a binary distillation column. Let's talk about A plus B only, when the feed contains A and B that need to be separated, and there is a difference in the boiling point of the two. Supposedly, let us consider that A is more volatile than B, A is having a greater volatility than B, and A is having volatility is high, and boiling point of A is less than B. BP of A is less than B. So clearly, it is seen that the A has a greater tendency to form vapor, or easily forms vapor under a low temperature, whereas B has a tendency to remain as liquid. So primarily, when we feed the A and B in the chamber, when both the, now there is a concept that the feed can be partially liquid, can be partially vapor. Again, depends on your design criteria that you are suiting to, or your previous chamber, that is the supplier that you are receiving the feed from. In industry, distillation column is a WIP, that is work in progress. So in a WIP unit, your supplier and your customer is very important. Your end product is received by a customer, and you are receiving the feed from a supplier. So your previous unit in an industry, what kind of material does it provide to you? Whether it provides pure liquid, whether it provides pure vapor, or it provides a combined mixture of liquid and vapor, that completely depends on the supplier that is supplying you the feed. So you see, depending on it, a lot of things will be governed. First of all, as soon as the feed is entered, let us understand this very carefully, my friends. As soon as the feed is entered at a particular temperature, say 50 degrees Celsius, as soon as it enters the chamber, it attains the temperature, it comes in contact with the liquid and the vapor of that particular plate in which the feed is fed. Now, this is also governed by the design of the distillation column, that where do we exactly need to inject the feed such that we obtain this much quantity of vapor at this concentration and this much quantity of liquid at this concentration. So you see that primarily, if we feed a mixture of liquid and vapor of A plus B, the vapor has a primary tendency to move up as it goes into the chamber, the vapor portion, and the liquid has a primary tendency to come down. Supposedly, feed is introduced on this plate, inlet plate. So the vapor will go up and the liquid will come down. Now what happens is, since the liquid also contains some amount of A and B, this A having a high tendency of forming vapor, as the liquid goes down and interacts with the vapor, incoming vapor in each of the plates, my friend. Remember this, as the incoming vapor interacts with each of the, as the incoming liquid and the vapor interacts in each of the plates, the concentration of A, there is a tendency of A moving out from the liquid phase to the vapor phase. Because A at a high temperature, as we go down, we are seeing that this is a reboiler. What is it? What is the work of a reboiler? Reboiler basically gives heat energy in the system. So it gives a Q. It gives the heat energy into the system. It heats up and feeds a portion back into the system. Feeds a portion back into the system, such that mixture collected at the bottoms is reheated and refed into the system, and it further forms vapor and interacts with the incoming liquid that is falling down the plates. So as the interaction happens, the temperature of the liquid at this plate will always be lesser than the temperature at this plate. This plate is having the direct heated reflux liquid from the reboiler, and hence the temperature is going to be high. As the temperature at this plate is high, there is a tendency of A to form vapor. So the tendency of A to form vapor being A being strongly volatile and having a low boiling point. So what happens is A primarily forms vapor and it goes into the vapor stream, mixes into the vapor stream, and the vapor stream moves upward. Now what about B? B doesn't have a generalistic tendency to form vapor, and B at this particular temperature also would like to remain primarily as liquid. So when B tends to remain as liquid, now talking about the upper half, that is the enriching section. Now this is called the bottom section and this is called the enriching section. So you see this distillation column, why is it called the enriching section? Because you see, as the vapor moves up, as it is coming further in contact with the incoming liquid, it is getting enriched in A. So in the vapor state, the concentration of A is increasing, and in the liquid state, B concentration is increasing. So as the vapor moves up, it entrains more and more amount of A within itself as vapor, because the liquid with high amount of A is coming in contact with the vapor, and the liquid has a tendency to give more and more amount of A into the vapor stream, because the A primarily has a tendency to form vapors at high temperature. So you see at the top what happens is A plus B again is going at the tops. So we see that it is passing through a condenser, and the condenser primarily loses heat. So a condenser may be partial condenser or total condenser, depending on again the design criteria. A total condenser is responsible for converting the entire of the vapor state, into the liquid state. So as the vapor converts into liquid, this liquid also primarily has A plus B. And as we see, when the liquid comes down, B moves in, A moves in from liquid to vapor state, and B moves in from vapor to liquid state. Why does B move into vapor to liquid state? Because B has a primary tendency to remain as liquid because it is less volatile as compared to A. Moreover, B has a higher boiling point, so it has a tendency to condense under low temperature conditions. Here the temperature is low because it is losing heat, and a part of the cold liquid, here cold liquid, is being refluxed into the chamber. Here hot liquid was being refluxed, hot fluid, and here cold fluid is being refluxed into the chamber, which is bringing down the temperature of this top plate. Once the top plate temperature is getting down, B immediately, the B that was present in the vapor state in the first plate is trying to condense back into liquid and is trying to trickle down through the trays back into the reboiler. So B at a low temperature on the topmost plate has a tendency to convert into liquid. So whatever B is being carried over by the vapor state at the top is being condensed into liquid at the top plate in the condenser itself, and finally in the reflux drum, and is trying to settle down into the bottoms. So as a result of this, what is happening, further and further amount of A that is being introduced with the feed is basically moving down and again coming up with the vapor state, whereas further and further amount of B that is going in with the feed is trying to trickle down as liquid, which is causing a primary tendency of B forming liquid at the bottoms and A getting enriched in the vapor at the top. And that's why it is called the enriching section, because A is continuously getting enriched in the vapor, and B is continuously getting enriched in the liquid and is collected at the bottoms. Now let us understand the concept of reflux drum. Reflux drum, as the name suggests, is basically putting a reflux back to the chamber at the topmost plate. So a part of the liquid, once the condensation is done, considering it to be a total condenser, the vapor being converted fully into liquid containing A plus B, primarily A in higher content, but B also may be present and will be present. Now further enriching needs to be done. So we collect it in a reflux drum, we put it in a reflux drum, and we send this liquid back into the chamber as a cold liquid, so that further interaction of vapor and liquid takes place with the liquid stream, and further enriching occurs, which means whatever amount, my friends, remember this, whatever amount of A is present in this liquid stream will get transferred to the vapor stream, and whatever amount of B was initially present in this vapor, which condensed back here and came into this liquid, this B will get reduced because it will have a tendency to come down or trickle down with the liquid state itself. So in the process, A is enriching in the vapor stream and B is degrading in the vapor stream. Similarly, for the reboiler, there is always a reflux, hot fluid reflux, that is going into the chamber, such that when we feed back this liquid, this primarily consists of B and traces of A, but there are definitely A traces, which when comes back into the chamber has a tendency to move up with the vapor, whereas B again is refluxed back or collected back into the reboiler. So B is getting enriched in the liquid stream at the bottom, and A is moving up with the vapor form at the top. So you understand this entire concept of it all. In the entire process, A is being enriched in the vapor stream, is again and again contacted with the incoming liquid which is going down. There's a primary interaction on each of the plates between the vapors and the liquid, and this is the concept of distillation. And because of the difference of volatility and boiling point, A has a primary tendency to move into the vapor stream trying to form vapors. B has a primary tendency to come with the liquid, trickle down to the bottoms, and there is always some part of the liquid from the reboiler and the reflux drum recirculating in the system to enrich the product and increase the quality. Now, more is the quality enriched, because we are in every reflux state, we are decreasing the quantity of B and increasing the quantity of A in the vapor state. Whatever is coming, we are condensing that, we are forming liquid, we are recirculating back to the chamber, thus undergoing more and more interaction, entering more and more A and reducing more and more B in the vapor that is being collected. So basically, reflux in any form is basically increasing the quality and is compromising the quantity, because more we reflux that thing back in the system, the lesser is the distillate. Lesser is the distillate that is collected and sent to the customer, my next customer. So we send the reflux, we are basically recirculating the same fluid again and again in the system, and we are not distillating it back. In some cases, to reduce the temperature, or when the separation efficiency is not that good, to reduce the temperature when the top temperature is increasing, to reduce that particular temperature, we need to undergo full reflux, that is 100% reflux with no distillate collection at all. These type of procedures are also being followed in the industry, wherein for some time, that is for half an hour or 1 hour, we need to undergo full reflux to decrease the temperature and increase the separation efficiency, so that the liquid formation is healthy and the vapor is enriched in A. So the amount of reflux decides the amount of distillate. The more is the reflux, the lesser is the distillate that is sent to the end customer. And moreover, here also, the more is the reflux from the reboiler, the lesser is the bottoms product that is being sent to the customer. For multi-component distillation, what happens is, primarily, supposedly A plus B plus C is present. C is having a low volatility, so C has a tendency to move up. A plus B is collected in the bottoms. Further, A plus B is separated in a different distillation column, wherein A is going to the top and B is going to the bottom. So 2 distillation columns is eligible for separating 3 components, and like this, for 4 components we need 3 distillation columns in series to undergo proper separation method. So you see that for multi-component distillation we need distillation columns in series, and this is a prolific method that is being used in the industry, wherein there is a difference in boiling point and there is a difference in volatility. So I hope you have understood the basic concepts and the uses of the reflux drum, the condenser, the reboiler, that is heating up the liquid and recirculating it back into the chamber, and the bottom product and the distillate, and how the interaction from tray to tray does occur, and how there is a mass transfer always occurring because of the tendency of A to form vapor and the tendency of B to primarily remain as liquid. And this is the concept of liquid-liquid separation that the distillation columns do follow. I hope you have understood. We will come up with more concepts like pump back reflux, pump around reflux, McCabe-Thiele method, Ponchon-Severide, as we have discussed in consecutive videos. alternative weeks maybe. I hope this topic is clear. Now coming to interview questions that you can expect, as I have told right at the beginning of the video, you can expect the design of distillation columns as one of the main interview questions. You can expect the conceptual questions like the work of the reflux drum. What will happen if we keep the reflux high? Will the quality increase or decrease? What will happen if we increase the bottoms product so the less amount of fluid is being recirculated? What type of control operators? I have discussed this in particular in the PFD to PNID video. What type of controls do you need? You need to have temperature control, you need to have pressure control. Different type of distillation columns like under low pressure, vacuum distillation columns do exist. When we need to decrease the boiling point, that is at a lower temperature, we need this to form vapors, we undergo a low pressure distillation column. Whereas in some cases, we need to keep the pressure very high and the temperature extremely low, like in cryogenic distillation columns, which are very famous in industry for the separation of oxygen and nitrogen from the air. The air that we take in, we need to separate oxygen and nitrogen. We know that the oxygen boiling point is minus 193 degrees Celsius and the nitrogen boiling point is minus 195.8 degrees Celsius. So in those particular cryogenic conditions, we need to have extreme high pressure and extreme low temperature to maintain the distillation column parameters. So different type of distillation columns exist depending on the pressure and the temperature that we use. Try to read through all of them: cryogenic distillation columns, try to read through multi-component distillation columns. So distillation columns can be segregated in different times depending on the feed, whether it is binary or multi-component, whether it is cryogenic or normal operating conditions, whether it is vacuum distillation column or normal atmospheric distillation column, which is very famous in crude oil refining once again. So these type of concepts are being generally asked in the interviews: work of a reflux drum, work of a reboiler. What if there is not a reboiler? Like in refinery industry, we do not use a reboiler, we use a steam stripping method. Why is it so? So these type of questions, we have answered that in the crude oil distillation video, you can refer to that. These type of questions are very common in terms of distillation columns and the design. We are going to come in details with the design sooner or later in the consecutive videos. I hope that is enough for today on the basics of distillation column. I hope the concepts are clear. If you liked it, like it, share it with your friends, subscribe to our channel. Thank you very much.